So we're in the guided practice packet on the very last page, and we're going to be looking at number 2. So first, how do I know that number 2 is a piecewise function? Because it looks awful. There is one function, but there are 3 pieces to it. Another key identifier of those piecewise functions is those if statements. The if statements tell us where we are going to have bound lines and where our graph is restricted to those certain areas. So folks, we're going to go ahead and make a table for each function piece. So my first function piece is f of x equals -2. I'm going to go ahead and do that. Let's do that over here. So f of x equals -2. And we're going to make a table big enough for 3 points just to get the general shape and location of that part of the function. Our next function piece is f of x equals 3x minus 4. And that's going to get a table as well. And folks, I strongly recommend writing those function names above the table so that you know where you are plugging in those x values that we will eventually pick. And our last function piece, f of x equals -x. So we make a table for each function piece. Now we're going to start looking at those bound statements, this if statement with the inequalities, because that tells us where we're going to draw our bound lines and how we are going to start our tables. So any value that you have in those if statements is going to represent a bound line. So I'm going to have a bound line, which we draw in as a dashed line at -1. We're going to have another bound line at 0. So I'm just taking the values out of those inequalities. Another bound line at 3. And same value at 3 as well. Now, folks, this one is slightly different than the ones we did on Friday because how many areas have those bound lines divided our graph into? Over here is area 1. In between those bound lines is area 2. In between these is boundary 3. And in between those is boundary 4. I have 4 different areas, but I only have 3 function pieces. So that means one of those bound areas is going to have no function at all, just blank, empty space. So folks, once we have the bound lines, then we can start using those bound statements to choose the values in our table. This first one, f of x equals -2, says we want x values that are less than -1. But what value do we have to start with? We have to start with -1. And that always throws students for a loop because it's like, wait, but -1 is not less than -1. We still have to start with -1 because that's what tells me that's where we stop being this function. It's not actually defined at -1, and how we state that is with an open dot at that value. Now for our next table, we have 2 bound values in that bound statement. We've got 0 and 3. So we'll have to use both of those bound values, and then we're going to get to pick another value in between those. Open dots or closed dots for those ones? Closed dots because it's greater than or equal to 0, plunk, and less than or equal to 3. So closed dot for both of those. What's the bound value for the last table? X is greater than 3, so we have to use 3, but since 3 is not an included value, since it's greater than 3, we use an open dot. So you always start the table with the bound values, but it's open or closed depending on the inequality sign. Any questions on that? Do we remember that from Friday? So now the fun part is picking the rest of the inputs based off of those same inequalities. Now, folks, this is the one that throws people off. I want x values that are less than -1. In which direction is less than -1? Over here to the left or over here to the right? To the left. If we want less than negative 1, we want to keep going in this direction. So negative 2 is less than negative 1, and negative 3 is less than negative 1. So less than or left of on our number line or on our axis. For our next table, we want to choose another value that's between 0 and 3. What's sounding good? 2 or 1, doesn't matter which one you pick, but I wouldn't pick something like 2.5 just because it's gross. Keep the numbers simple so that they're easy to graph. For our next table, we want x values that are greater than 3, so 4 and 5. And folks, to me, that is the toughest part about these piecewise functions is choosing the inputs. That's what these x statements mean, is they are limitations on what x values or inputs we can plug into each of those function pieces. From here, we are going to plug those values in to each of those pieces. So if I plug 3 in for x, what am I going to get for a y value? Negative 3. So negative 3. If I plug 4 in for x, negative 4. If I plug 5 in for x, negative 5. And let's go ahead and plot those points. So 3, negative 3, make a big open dot. 4, negative 4, 5, negative 5. Are we going to draw our arrow up and to the left or down and to the right? Down and to the right only, because this is where my x values are greater than 3. So here's 3, my x value, and then greater than 3 is this part of the graph. All right, that's my first function piece. On your own, I want you to try the blue one, and if you get done with the blue one, try the pink one. Plugging those values in and then plotting the points. All right, folks, plugging in for our blue table, 3 times 0 is 0, minus 4 is negative 4. 3 times 1 is 3, minus 4 is negative 1. 3 times 3 is 9, minus 4 is 5. So we are going to have 0, negative 4 with a closed dot or a regular dot, bless you. We are going to have 1, negative 1, and then 3, 5. And are we going to have arrows on this line? Nope. It's sandwiched in between two bound lines, which means it can't go over in this territory, and it definitely can't go over here. Folks, if we started going over here to the right, what would happen is we would fail the vertical line test, and then it's no longer a piecewise function. The functions always go from bound to bound. They never cross into the other function area. So, folks, if you got to the pink function, what's different about this one when you start trying to plug in those x values? There's no x to plug in for. Remember, f of x equals negative 2 is the same as y equals negative 2. So we're going to take that and autofill our y column with it. If this says y equals negative 2, that means that's the only thing that that y value can be equal to. So negative 2, negative 2, negative 2. We call this function a constant function because it is just equal to one solid value. This is going to be important as we start doing these yuckier looking step functions. So this is a constant function. When we plot that, backwards 1, down 2, nice big open dot, backwards 2, down 2, backwards 3, down 2, and we get a horizontal line, which makes sense because it's a solo y equation, or a constant function extending to the left. So the only place where we don't have a function piece is right in between those two bound lines. So that's just empty space there. We don't have any function pieces at all. Folks, any questions on how we got the bound lines, how we made the tables, or how we did the graph? All right, then, I want you to try number 3 and get as far as you can in 5 minutes. 5 minutes on the clock.